everyone. I am Dr. Jimmy Mehta, currently working as an assistant professor in the Department of Mechanical Engineering, School of Engineering, Manav Rachna University. I have over 11 years of experience in academics and research with specialization in coating technology, tribology, material science, and surface modifications. Today, we'll talk about material science and why is it so important for us as mechanical engineers. Today, we'll discuss about the material science and it has 5 basic modules. Number 1 would be the crystal structure. Number 2, the properties of materials. Number 3 would be basic heat treatment. Number 4 would be alloys and the composites. And lastly, the 5th one would be smart materials and 3D printing. Material science forms the backbone of mechanical engineering because every design, mechanism or machine we create is fundamentally dependent upon the materials we choose. It integrates the principles of physics, chemistry and engineering to understand the structure, property, processing, performance relationship of materials. Whether we are designing high-strength alloys for aerospace, wear-resistant coatings for tribological applications, or lightweight composites for automotive systems, our ability to select and engineer the right material determines the overall efficiency, safety, and sustainability of the product. In simple terms, mechanical engineering is not just about designing systems, it's about ensuring that those systems operate reliably under real-world conditions and that depends upon the science of materials. One of the most fundamental concepts in material science is the crystal structure. Most engineering materials, especially metals, are crystalline, which means their atoms are arranged in a regular, repeating, three-dimensional pattern. This arrangement influences how strong, ductile, hard or conductive a material is. To describe these arrangements, we use the concept of a unit cell. Think of the unit cell as the smallest repeating block of a crystal lattice. Just like the brick repeats to form a wall, the unit cell repeats itself to form the entire crystal. These are the different types of unit cells found in metals. Simple cubic. Each corner has one atom. This structure is rare in real metals because it is not very efficient in atomic packing. Body-centered cubic (BCC). One of atom at each corner and one is in the center. Found in metals like iron, which is at room temperature, chromium and tungsten. These structures usually provide high strength but have lower ductility. Face-centered cubic. Atoms are located at each corner and in the centers of each face. These are found in aluminium, copper and gold. These structures are generally more ductile, more malleable and make them easier to work with. Hexagonal closed pack (HCP). These are found in metals like zinc, titanium and magnesium. These structures also allow close packing but has limited slip systems, so these metals tend to be strong but less ductile. Why is this important for us as mechanical engineers? Because these atomic arrangements determine how a material behaves under stress, heat or load. For example, steel, which can exist in both BCC and FCC forms depending upon the temperature, exhibits different properties when heated and cooled, a principle utilized in heat treatment. Aluminium, with its FCC structure, is lightweight and ductile, which is why it is widely used in aerospace and automotive industries. Tungsten, with its BCC structure, possesses very high strength and melting point, making it ideal for cutting tools and high temperature applications. So, when we design machines, we just don't think about the geometry and mechanics. We also need to choose materials wisely based upon their crystal structures and resulting properties. A few critical factors include the longevity and fatigue resistance and the cost effectiveness, which is equally important as environmental sustainability. At its heart, material science deals with the relationship between structure of materials and their properties. Whether we are designing an engine or a turbine blade or even a small machine part, the performance of that component depends not only on the design but also on the chosen material. Lastly, material science bridges the atomic world with the engineering reality. Material science provides us with the foundation to connect the invisible world of atoms with the visible world of machines and structure. By understanding this crystal structure and unit cells, we gain the ability to select, process, and innovate with materials, ensuring the efficiency, safety, and performance of engineering applications. Material science provides us with the foundation to connect the visible world of atoms with the visible world of machines and structures. By understanding crystal structure and unit cells, we gain the ability to select, process, and innovate with materials, ensuring efficiency, safety, and performance in engineering applications. Material science is crucial in mechanical engineering because it helps us to choose the right material having strength, having durability and performance. It ensures how the material reacts under stress, under heat and environmental conditions, ensuring safety and reliability. In the next module, we'll study about the properties of materials, and those may include mechanical properties, thermal properties and electrical properties. Thank you everyone.